so crazy. If you think a 6 metre sheet's long and hard to handle on site, I'm not allowed to say how long it is, but it's very long. There's no way you'd lift it. This gets put in there, and this mud gets put between it, and then
this board here is wet now, but it's currently setting.
last year we did a Why New Zealand Loves series, and one of the products we focused on was jib. Here in New Zealand, jib has a 94% share of the plasterboard market, with the closest competitor, elephant board, only holding 3%. And what do you know? They saw our video and invited us here. Let's go and have a look around, and we'll chat to some of the people behind the plasterboard that you love in New Zealand, and we'll look at how it's made.
Just see it.
You're right.
This is where the magic happens. They take the raw ingredients, put them together, and turn it into plasterboard.
This one building's about 50,000 square metres.
Well,
One building space, so
Right.
yeah, shoot.
the process starts with gypsum. This is the core ingredient inside the 2 layers of paper. It's mainly sourced from Australia and shipped through the local port. It's moved from the ship into this huge holding bay. So that's what a shipload of gypsum looks like.
Not quite, that's probably about 2/3 of a ship.
This is Simon, and I had the pleasure of hanging out with him for a day. Not only is he the brains behind the design of this factory, but he is mad passionate about plasterboard. For some reason I thought it was going to be white.
Yes, so natural gypsum comes in different colours and different rock shapes. Depends on the mine you get it from.
Yeah. Hold up, I don't think the video explains the scale of what we're looking at. Man, this is huge. This is crazy. It's just like a mountain. See this payloader here? That's 2.5 times my size, which means this mountain of gypsum is huge.
Okay, so it is a natural material. Well, gypsum's a very, very common material around the world. So most older land masses will have lots of gypsum. Geologically, we're just too young to have pure deposits of gypsum in New Zealand.
The team feeds the raw gypsum onto the line to go through a heating grinding process, refining it down to a powder-like consistency. Jib makes a range of plaster products, and they each have a unique mix of gypsum powder, additives, and water.
So the first thing we need to do is take gypsum, which has it's a calcium sulfate molecule with 2 water molecules bound to it. And to convert gypsum to plaster, all we're doing is driving off 1.5 of those water molecules. So we need heat and therefore energy to do that conversion. Yeah. Okay. So that's what happens in this high bay tower over here.
And that takes gypsum into plaster.
Into plaster. From plaster, we then put it through our ball plant mixer. We add water back in again to help it set. And basically what we do is we're rehydrating those calcium sulfate molecules back to gypsum.
So this is mission control for jib production?
Yes, for the board line, this is our main control centre. As you can probably guess. Mission control, we call it. That's the master shutdown.
Should we push that button?
Yes, you might be escorted off site if you hit that button.
Yeah.
So we can control most of the plant functions from this facility here. Modern ball plant, highly automated, so we've got a huge amount of computing power in the background trying to drive everything. Depending on the product, we can run the entire factory on 8 or 9 people.
From here, it's moulded to the required thickness and set between 2 paper sheets. Or, in the case of Weatherline, a purple fiberglass sheet. this gets put in there, and this mud gets put between it, and then
Yeah, so every product family that we have, whether it be 10mm Jib Standard, 10mm Jib Aqualine, all has different product formulations. We adjust the colour path for the different thickness of products. We can also adjust some of our width guides, whether we like the 600 wide board, 1200 wide board, or 3050 wide.
So that can do a 1350 wide as well.
Absolutely, everything can be done on this machine.
so crazy. If you think a 6 metre sheet's long and hard to handle on site, I'm not allowed to say how long it is, but it's very long, it's huge, it goes that way and there's no way you'd lift it.
This board here is wet now, but it's currently setting. Once it's set, we can sort of cut it and move it around a corner, but the board's still going to feel very, very damp. It's going to still have a pretty high water content. We'll get over to this side. Very careful around here, eavesdrops again. You might want to see if you get a close-in shot on this one, you're allowed to.
Yeah,
So this is where we first
Where
cut
is
the board.
the edge stops?
You can zoom in on that.
So this is the cutter?
This is the cutter. This is the wet-end cutter.
Wow.
Where we first cut the board. So there's a top and bottom knife, and they just rotate to cut through the board.
Oh, true.
Yeah, so you see it.
So crazy. There's two knives rolling, and at the same time they roll and cut the top and the bottom. Imagine having one of these on site to just perfectly cut your jib every time.
You think what you asked is how long is that board before? It's actually 2, 6 metres put together.
Oh, yeah. Tell us about the tipple.
Well, the tipple's just a device which allows us to index product into each of the different 10 decks of the dryer. So if you watch it here, it will then cycle to a new deck every now and again to make sure we can feed the product across those full 10 decks. Yeah, Europe and North America based on that. So it comes out of the dryer, it's at the right moisture level, it's nice and warm, surface temperature is probably over 80 degrees. From here on in, it's all about trying to just finish it, cut off any sort of rough cut edges, book the board, apply our end tapes and put on the pallet. Not quite, we're going to apply end tapes. This is our bundler. Just where we're putting the product onto pallets for transfer to our warehouse.
There's a few more sheets here than the local ITM. After being stacked and packed, the plasterboard is ready to be trucked off around the country. Everyone we met here was super switched on. From Simon, the main man who helped bring the factory to life, to the super smart Estelle, who's not only a chemist but an international rugby referee, and Victor, the continuous improvement manager.
Yeah, so I'm Victor Feldman. I'm the continuous improvement manager.
The job that never ends.
Yeah.
I definitely felt like the dumb one in the room because almost everyone here had super high level postgraduate degrees.
I studied back home process and chemical engineering.
Also studied chemical engineering.
There's a theme on this side of the room.
Yeah.
You all love science and white powder.
Yeah.
But what stood out the most to me was not the smarts, it was the pride that everyone took in their work. You can tell that they genuinely care not only about what they're making, but the work environment they're in. There's a culture of backing each other up. We saw this on the notice board full of team shout-outs.
So anyone can use a shout-out card to give to anyone else. And they're all like, glad to have you on board, you rock, I love the cut of your jib. Just stuff and give them to each other in order to recognise something that they've done well and have really contributed to.
And I'm not just saying this, we felt it. Everything from the notice board full of team shout-outs to the way that they interacted and smiled at each other as we walked around. You can tell that it's not just a job to them. They actually believe in the product they make and the company they work for.
Hello. Cameras are arriving. Run, Luke.
Run away.
So I'm here in the Jib Lab, top secret laboratory, with Estelle. Estelle is a process chemist, is that right?
Yep, chemist, lab tech. Yeah, we do mainly testing, so raw material in process and final product testing.
System, has to be as a structural system.
So this is basically raw gypsum.
Yeah.
So we process this into this.
So that's what we saw in the big gigantic pile
Yep.
out there, and then that's gone through the process of going from gypsum to plaster.
Yeah.
Hello,
Josh, welcome.
thanks for having me. Simon is one of many long-standing employees that have been with Jib for over 20 years.
Been with the organisation almost 25 years, which in terms of years served is actually not the highest in this room.
And you can tell straight away he absolutely loves what he does. Did you always know you were going to end up an engineer?
Yes, absolutely. So engineering was my passion. Loved putting things apart as a kid, putting them back together again. So from a very early age, as early as I can remember, I always wanted to be an engineer.
I heard you designed this place.
Well, I was involved from the project at the very outset. In terms of design, very much involved in the scale of the part that we want to build, the type of technology we want to use. But for a part of this scale, we needed a design team of over 100 people to deliver the project in the state that you see it today.
You'd have like the physical building, and that's one thing, and designing that to be fit for purpose. But then you're also then putting all this amazing equipment in it, which is a whole little job on its own, eh?
Yeah, and I think the complexity of the build is the fact that for some parts of the plant, we had to build the building around the equipment. So effectively the building is the support frame, the structure to hold up the equipment.
Really?
And all we have is cladding around the outside.
Like this, for example, with that?
Yeah, this is an example whereby we had the build team trying to build the different levels of this plant, but if you look at how congested it is in some areas, we just sort of pause the build program to put a bit of gear in, then recommence the build program around that bit of gear. So by world standards, this would be what we would classify as a medium-sized plant. But in the Southern Hemisphere, we think it's one of the largest, if not the largest plasterboard plant in the Southern Hemisphere. Most parts of the world, when they design plants of this size, they'll maybe run 3, 4, 5 different products. Now have another plant down the road which will do other sets of products. We can't afford multiple our plants in New Zealand, so we've had to design a plant which could do our entire product range, whether it be 600 wide barrier line to 1350 wide, wide line to the weather line products. This part's designed to do pretty much everything.
In my opinion, that's what makes the factory such a special place. One site purposely built, ready for the future. Here's a crazy stat. The new facility can pump out more plasterboard in one day than an entire year in their original 1927 factory. If that's not continuous improvement, I don't know what is. What I observed is that every single part of the process has been dialed in. Precision, speed, consistency.
From sample to test, it can be on the line within 3 hours.
Super smart chemists like Estelle know all the details about exactly what those gypsum molecules are going to do. We observe some of the tests that they constantly run to maintain quality and consistency. How are you doing?
Yeah, good, thanks.
I hear you are the continuous improvement manager.
Yeah.
Yeah?
Yeah.
Big title, big shoes to fill.
Yeah, especially with a brand new plant, you would think that no continuous improvement is really required. But I mean, that's and as you would know as well from all building products, we continuously push the boundaries and what's possible.
And Victor's always improving, chasing better drying times, better mixes, and that next bit of efficiency.
If there's new raw materials that we can test and try to make things better on the plant side, on energy, sustainability, recycling, and then quality and product performance. So straight through the bank from start to finish, we try to optimize and improve.
It sounds like there's been an insane amount of thought go into it behind the scenes.
Exactly, yeah. The plasterboard you guys see on site is there's a lot of thought going into it.
All of those have different specifications and different widths. Yeah.
Not only is it a well-oiled machine, but the place was cleaner than any building site I've ever been to. No dust, no clutter, just lots and lots of efficient production. It's very clean, by the way, and I'll talk about that, like the lack of dust.
It's not clean enough. There's always room to improve, right? As I said before, always room to improve.
You can tell that they take pride in not just what they make, but how they make it. And I think when you buy off a Kiwi company, you want to know that they care about both sides of that equation. It would be impossible to run a business this big without good people and solid systems. What stood out to me the most with my factory visit was how everything had a place and a system and a process. Like any good factory, they're tracking everything from the gypsum in the board to the production line to where it's stored and moving it on after that.
The computers themselves will be monitoring all the raw materials going in, all the process parameters. So really the operator's role is to feed raw materials in at the front, remove finished product off the line at the end, and then be monitoring and observing and making sure everything's running as it should do.
One of the things that stood out to me the most is they've worked out how to incorporate all of the waste and all of the offcuts back into new mixes. These days we know it's not just about the product you're making, but the sustainable steps you're doing along the way.
That is our end-saw waste recovery system. So when we finish the end of the plasterboard, we trim off the ends to create a nice smooth end of each plasterboard. And that little trim waste goes through this pipeline here and back to our recycling system to be recycled into new plasterboard.
Take the core ingredients, for example. Gypsum is a natural product and the paper is 100% recycled.
So we've got environmental certifications. So part of getting those certifications, we have to get declarations from our raw material providers. So that includes the gypsum mines and the paper manufacturers. So we go through quite a process, and that gets audited to ensure that they're doing the right thing as well.
And they're not only including all of the factory offcuts in their mix, but they're experimenting with taking builders' offcuts and putting those into the mix as well.
Okay, so on this side of the shed is where we're having our recycling operation. So we are recycling not only our internal waste, but we're also starting to take back off-site waste and putting that through our plant. So right now, today, around about 4 or 5% recycled content in every bit of new plasterboard made in this plant. We have tested the system up to 10%.
Yeah.
So our bottleneck now is how we can economically recover waste from building sites and get it back to this facility here.
They recycle all their water.
So we have no trade waste off the site. All our wash water, all our wastewater, we recycle back and make it into new plasterboard.
Tell me about this chimney. Are you guys pumping lots of dirty air?
Okay, so to clear up a lot of myths, I can tell you that is steam that you see coming out of that stack. So a big part of our process is drying the plasterboard. We use a lot of energy to dry. So what you're seeing there is the water we've effectively evaporated off the product inside our process.
So while you're drying it and the steam evaporates, you pull the heat out of that and then pump
and
it back
recycle
in.
it back in again. So
Yeah.
this will be one of the most efficient board plant dryers in the world, and allows us to reduce our carbon footprint with this plant. Now in the background, where the main stack is, we've got a whole lot of machinery below the stack. That's called a wet electrostatic precipitator, or a WESP. That's designed to clean out ultra-fine particles out of the airstream. So we use high voltage to attract ultra-fine small particles out of the airstream. So what you're seeing come out the top there is very, very clean emissions. To our knowledge, this is the first time anyone in the world has put a WESP into a plasterboard plant, so we're pretty proud of that.
Investments in smart lighting, heat recovery systems, and better thermal performance have resulted in a 10% reduction in emissions. And we know that if Victor's on the case, these numbers will continue to improve.
This is actually gypsum, what it starts out as, where it comes out of the dirt looking like. And the name Gib actually came from the Rock of Gibraltar, and then it got turned into Gibboard, and then it got shortened down even further, and now it's just plain old Gib, but it's made out of this stuff.
Thanks again.
Take care.
Thank you. Yeah.
Whoa. That was mind-blowing. I think there's two things that jumped out to me, and one of them was really hard to capture on video, but it's the scale of this building. Full open span, end to end, it is huge. But what I've also noticed is that it was clean, it was organized, it was safe, and on top of all that, we have met so many amazing people, from chemical engineers through to manufacturing masters and everyone in between. I've left with a huge appreciation for the product we are putting on our walls. Thanks again, Jim, for having me and showing me all of the love, care and effort that you guys put into a product we use every day.
Perfect.
Boom.
Yep.